My goal is to get through lesson 5.2 today, and based on the fact we have a limited number of days left before the end of the semester, I kind of have to keep with my goals here. So I have to make it work some way or another. Lesson 5.2 kind of picks up, and if some of the things we talked about yesterday carry along, we're going to be using that whole idea of in behavior and turning points that we talked about from yesterday, and we're going to be talking about those some more today. But we're looking at factoring polynomials, we're looking at writing polynomials, and we are also looking at some graphs. Okay? Question, Carter?
It isn't a big deal, but like, is there a reason like why it's like cut up kind of weird?
Because, okay, so at one point, lesson 5.1 and lesson 5.2 were done together, okay, and I've separated them. Okay. So I took these notes from a previous teacher, Miss Byers, and she taught them together, and I didn't like that. So I've separated them, but I haven't taken the effort of retyping them myself. Does that, levels of how much I want to effort there. So yeah, so that is why we're starting on example 3 and all that. Okay. So first of all, writing a polynomial in factored form. I'm going to go with technically, this is nothing new. Okay? You can factor. You have factored. So that's what we're being asked to do here. What is the factored form of each of the following? So x cubed minus 2x squared minus 15x. What's the first thing I always try and ask you when we're factoring? Okay, well, yeah, we can look at is in standard form, which is going to be helpful. And so are these in standard form order? Yeah, they goes highest exponent to lowest exponent. But then when you actually factor, is there a GCF? Okay, always be asking yourself, is there a GCF? As we look at example A, is there a GCF between those three terms? X? Anything else? No. So since there's an X, if you recall, that means I'm going to take this X and I'm going to put it out front of the parentheses, and I'm going to divide everything by X. Now, do some of you appreciate this visual still of me showing that I'm dividing by X? I'll be honest, I don't do that a lot, but I know some of you probably still appreciate it. What's x cubed divided by x? X squared, because when you're dividing with variables, you subtract the exponents. So 3 minus 1 makes us x squared. Minus, what's 2x squared divided by x? 2x. Because you're subtracting, you're basically taking an x off of there, right? Minus 15x divided by x? 15. Okay. Once you have a GCF, the question always becomes, are you done? Sometimes yes, sometimes no. Am I done here? Is there any more factoring that could be done? Okay, we've got our GCF. The key is think about other factoring methods.
Yeah.
Can we do the product and sum? Well, here's what I'm going to say to that. We should at least try. Maybe we can, maybe we can't, but we at least need to try. So when I talk product and sum, work with me here and focus, please. We need a product, so I need two numbers that multiply to be what? Negative 15, always the C term. And two numbers that give me a sum, or they add to be negative 2. What can multiply to be negative 15 and add to be negative 2? A combination of 3 and 5. I got that. Did we all get the right numbers there? They multiply to be negative, opposite signs. So a positive and negative. To add to be negative, bigger number, negative. So negative 5 and positive 3. Okay, so how do I write that out? What about this x out front? Do I need it? We need it in our final answer in that you should always just carry it down. Don't lose it, because you would lose a portion of your answer, which would be a problem. And then, since we just did product and sum, we're going to break this into two parentheses. X squared breaks into x times x. And what numbers am I putting in there? Minus 5 and plus 3. Or plus 3 and minus 5. Does it matter which parenthesis you write first? No. Okay? Am I done now? Yeah, I'm done now. There's no other GCFs. I factored into those individual, what I would say, linear factors. So I'm done now. That's review, yes? They throw it back again in this chapter, but that's review. So the good news is, if you're still struggling with factoring, it's another opportunity to pick up on it, right? That's why I keep reteaching it. Okay, B. Factor. What's the first question you're asking yourself? Is there GCF? They all have an X, don't they? Do they have anything else in common? Okay. So I'm going to put that X out front. Divide each term by X, right? Do you want that visual or not? I don't know if any of you use it or not. There's the visual if you want it. X cubed divided by X. X squared. Minus X squared divided by X. X. Minus 12X divided by X. 12. Am I done? No, because we're going to hope that we can product and sum this. So we need two numbers that multiply to be negative 12, and they add to be that invisible negative 1. And keep in mind, we can do this the easy way because there's nothing in front of x squared, right? If there's a number in front of x squared, we'd have to change up what we're doing. Okay. What pair of numbers for 12 are you wanting to use? 3 and 4 because they subtract to be 1, yes? Positive 3, negative 4?
Yeah.
I can go with that because they multiply to be a negative, so I need one of each. They add to be a negative, so a larger number is negative. Okay, how do I write out my final answer?
Drop the X down.
Don't forget to bring that X down. So I've had people telling me here, which is good. 2 parentheses. X squared is X and X. So X minus 4, X plus 3.
When you factor, what happens to that other X in the parentheses?
This X?
Yeah, the one X.
It would happen when you FOIL. It would be when you multiply your outsides and your insides. It would add to be that.
Oh,
Okay. I mean, the factoring technique we use is just kind of, a technique to get that, but the X is still in there. Okay, moving along then. Example 4. It asks, what are the zeros of this equation? Y equals x plus 2, x minus 1, and x minus 3. And it asks us to graph the function. So we're going to sketch the function here. Zeros. We've used that word before, I believe. I'm trying to think if I've used it recently or not. I might not have. Do you remember what zeros are? I think I've used it before. I should have. Mrs. Rogers should have used it. Wait, you guys didn't necessarily have Rogers, so. Still, anyone teaching Algebra 1 should have used it at some point. Do you remember what zeros are?
It's being associated with the number 0.
Don't forget O.
Yeah, I mean, maybe so.
Okay. Zeros. So you actually found zeros on your last test. I don't think I used the word zeros though, because zeros were when you took your equation and you took each factor and set them equal to 0. When you were finding your solutions, to the equation, you were finding your zeros. So you have found zeros before. Obviously, I failed in that I didn't use the word zeros like I probably should have at some point. That's on me at that point. And here's what I know, and I don't know if the current ISTEP does, but I remember students, it's been a handful of years ago, coming back from an ISTEP, and I felt so bad because they asked us about zeros. I don't know what a zero is. And I'm like, oh, yes, you do. I just might not have used the word as much as I should have. So, off to the right, I'm going to make a quick vocab list. The idea of zeros. Okay. Zeros are the same as x-intercepts. And when I say x-intercepts, I'm talking about where the graph crosses the x-axis. They're also the same, I just used the word solutions, right? They're also interchangeable with the idea of roots or solutions to a problem. Okay, so if we're asking for the solutions or the roots of a problem, we're asking for zeros. We're asking for the x-intercepts. Now, not exactly equivalent, but it ties in with the idea of linear factors. And I'm going to use that in this problem in a moment. So, those words, I mentioned all those words together because they all tie together. Zeros, x-intercepts, roots or solutions, and linear factors. Now, let's look at this example that asks us for zeros. Okay. Your zeros happen when you take the equation and you set it equal to 0. When it's y equals, that basically means we're putting 0 in place of y. Because x-intercepts happen on the x-axis when y is 0. So first thing I'm going to do is I'm going to take this equation, x plus 2 times x minus 1 times x minus 3, and I'm going to set it equal to 0. You guys got your vocab words down so I can zoom back in. Now, the nice part about setting this equation equal to 0 is this equation is already factored. Okay? Those are what we call linear factors because they each have a power of 1 in them. But if you saw this on the last test, how would you solve this?
Would you set them all individually equal to 0 and then add or subtract over your constant?
What you guys often saw in the last test is you saw two things multiplying together to equal 0, yes? And once you got 3 factored and you had 2 factors multiplying to equal 0, you set each of those 2 equal to 0 and you got 2 answers, right? In this case, I have not 2 factors, but 3 factors. And we're going to set them each equal to 0. So I'm going to set x plus 2 equal to 0, x minus 1 equal to 0, and x minus 3 equal to 0. You know how to solve those, right? If it's x plus 2, I'm going to subtract 2. And when I subtract 2, I get x equals negative 2. If it's x minus 1, we're going to add 1. We get x equals 1. If it's x minus 3, we're going to add 3, and we're going to get x equals 3. What did I just find? The zeros. Yes, they're my solutions, but they're my zeros. Now, notice when I was giving you words off to the right, I said zeros are the same thing as x-intercepts. So that means when we go to graph this, what also are these? When I go to sketch my graph here in a moment, these are also my x-intercepts, which will be good in drawing our graph. Okay? Now, think back to yesterday and end behavior. Before we sketch this graph, I want to talk about end behavior. What did we have to know to determine end behavior on yesterday's homework? Kendra?
If A was positive or negative, and if the power was even or odd.
Okay, so if A was positive or negative and the power was even or odd. And that was looking at, when you had everything multiplied out, the highest term, right? The highest power. Do I have everything multiplied out here? No. Do we want to have to multiply everything out? And you don't want to unless you have to, right? Now, good news is on this one, we don't have to. So let me write my equation. It was y equals x plus 2 times x minus 1 times x minus 3. That was the given, yes? Think with me here. I'm not going to multiply it all out. But if I were to multiply it all out, what would my first term end up being? X cubed. Because if my first term would be the result of multiplying x times x, which would give me x squared, and then eventually you'd have to multiply that x squared by this x, which is x to the third. Are there any numbers in front of those x's? No. So what I know is that this problem, there's my multiplying out. This problem is going to be x cubed plus something, 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 yada, 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 dot, dot, dot. I don't need to know that because right here, x cubed tells me my end behavior. The power of 3 is odd. So odd powers either had up, down, or down, up. This is a positive x to the third. So what's it going to be? Reverse it. Down, up. And think about a positive x to the third. What's the basic shape of x to the third, guys? That's how I remember it right there, yes? That's basic x to the third. That starts down, ends up. So because this is x to the third, I know my end behavior is down and up. What's your guess? Are you going to guess we have a pair of turning points? Are we going to have other x terms besides just the x cubed once we multiply this out?
Yes.
Yeah, most likely. You're going to multiply that out. That stuff's not all going to cancel. Remember, they occur in pairs, so we can expect to see 2 turning points. Now, trying to put myself a sketch of the graph here. Okay, so think about everything we've talked about. What do we know is on this graph? What did I say those zeros are? X-intercepts. So where do I know 3 points on my graph are? On the x-axis, -2, 1, and 3. So I'm going to put dots there. -2, 1, and 3. I know my graph goes through those points. Guaranteed. Now, I got my zeros, my x-intercepts. End behavior. What do we say the end behavior is going to be? Down and up. Meaning, down means I'm going to start down over here. Up means I'm going to end up over on the right. That's what down and up means. On the left, I start down, coming from the bottom. On the right, I'm going to end up. And I just kind of put those arrows to help. Now, we also suggested that there's probably 2 turning points. And we have to go through all those dots on the x-axis. Can you see what this graph's going to do? It's going to start down. It's going to cross up through -2. It's going to go up and it's going to turn. It's going to come back and cross through 1. It's going to go down and it's going to turn and cross up through 3. Now, do we know how high or low this graph is going to go? No. You get to make it up as you go. This is this an official graph? This is a sketch. Okay? When we sketch, I'm not looking for all the values to be precise and exact. What should be as exact is the x-axis places you cut through, so your zeros, and the shape. Do we all have the same shape? Okay, that's what I'm looking for when we graph something like this, is that we have the same shape. Okay. Got it? Okay. Yes?
How do you know what shape the graph is actually going to take? Is it always...
Well, that's what our end behavior was telling us. Because our end behavior was telling us where we started and ended. And then we had our zeros to cut through. So at that point, it's just a matter of being able to go up and down and get through them. Okay? I mean, it really comes down to the end behavior was, besides the zeros here, the end behavior was the other key thing. Because without the end behavior, we wouldn't have known, do I start down here or do I start up and this is all reversed? Okay? Yes?
How do you tell from within the equation how many turning points there are?
It's just a matter of the fact that they occur in pairs. And, gentlemen, there can never be more turning points than the highest power. So here, my highest power is 3. So that means I either have no turning points or I have 2 turning points. And we're not going to work with turning points past that. Okay, we do very little with turning points, but just to get you an idea there. Okay. Okay. Let's quickly go through this next example. Because I've got to get the one at the bottom and I've got to get one on the back to make sure we have a little bit of everything today covered. Okay. How do I find zeros? Set them equal to 0. So officially that means my whole equation gets set equal to 0. If I want to be official. So essentially my y becomes 0. So I have x times x minus 3 times x plus 5 equals 0. What are the parts I'm going to do here then? Yeah, that first x, set it equal to 0. Yes, you need to. Yes, it is important. So x equals 0. X minus 3 equals 0. X plus 5 equals 0. Solve those, right? Good news is x equals 0 is already solved. X minus 3 becomes x equals 3. And x plus 5 becomes X equals negative 5. What are those I just found?
Zero.
The zeros and also the x's, and the fact that it's the x intercepts. What about end behavior? Is anything going to be different than the last problem with end behavior? If I multiply this out, what's going to be that highest power? Well, x times x here would be x squared, but then you'd also have this x. And so that is going to make x to the third. The fact that this one right here, yeah, nope, it's still, because if you think about it, you can think of it as foiling these two parentheses and then distributing an x. So foiling these two gives me x squared. Distributing an x is going to make it x cubed. So, same in behavior. It's a power of 3. Use that chart that I gave you yesterday. It's a power of 3, which is up, down, or down, up. It's positive, which tells me it's going to be down and up. Are you expecting to see turning points? Yeah, if you multiply this out, there's going to be other terms. So expect to see 2 turning points. And once we go to graph it, even without knowing that there's going to be 2 turning points, you figure out that there has to be 2 turning points. Okay, sketch yourself a graph. I just went over as far as I had to. I went to 3 on the x, negative 5 on the other way, on the negative x. Okay. Did you put your zeros on? Where do I put dots for zeros? 0, 3, and negative 5. Right there, folks, you've got 3 zeros. That tells you there has to be turning points. My end behavior of down and up tells us where to begin and end. Yes? So, it's a lot like the last problem, isn't it? You're going to start below negative 5. You go up through negative 5. You're going to have to turn and go over and go through 0. And then you're going to have to turn and go up and go through 3. And you end up going up and away from 3. Yes?
Is there a way to know exactly how high the swells have to go on these?
There is, but not at Algebra 2 level.
Okay.
How's that? And that is not something we are going to address at this stage in your math career. Yes? Okay. Okay, when you're ready, start looking at example 5. What is a cubic polynomial function in standard form with zeros, negative 2, 2, and 3? So, a cubic polynomial function in standard form with these given zeros. Okay, guys, think about it. Those zeros, how do I put them in an equation form? How do I put them in a function?
Do the work backwards.
Do the work backwards. It's a good way to think about it. So, like the 0 of negative 2, where would a 0 of negative 2 come from? An x plus 2? Does that make sense?
Yeah.
Think about where these zeros on the previous problem were coming from. Okay, like a 0 of 3 came from x minus 3. A 0 of negative 5 came from x plus 5. Can we do the same thing here? So a 0 of negative 2 comes from x plus 2. It's always the opposite sign. What about 0 of 2? It's x minus 2. What about a 0 of 3? X minus 3. So if we're trying to write a cubic polynomial, we're going to take those three factors and put them together. Because I said function, I'm starting off f of x equals, and what are my three factors? X plus 2 times x minus 2 times x minus 3. Now, can I leave it in that factored form? What did the directions ask for? Standard form, which means they want it. Okay. Technically, it's going to be more than just ax squared plus bx plus c, but the idea of multiplied out highest power to lowest power. We're actually going to have ax cubed here is what we're going to end up with. Okay, now, how do we multiply 3 sets of parentheses? Okay, put 2 of them together, get that answer, and then we'll incorporate the third. You can pick any 2 you want. Me personally, I'm going to pick x plus 2 and x minus 2 because they're conjugates of each other. They're going to make life a little bit better. So, FOIL, x times x, x squared. X times minus 2, minus 2x. Now I'm going to distribute my 2. 2 times x plus 2x. 2 times negative 2, minus 4. My recommendation, keep carrying down the x minus 3 every step of the way so you don't forget about it. So easy to forget about. I would clean up what we just did. What do you know about x squared minus 2x plus 2x minus 4? So nice when that happens. That negative 2x and plus 2x, those inside terms, cancel. So then I have x squared minus 4 times x minus 3. And again, we multiply. So I'm going to distribute my x squared. X squared times x, x cubed. X squared times minus 3, minus 3x squared. Distribute your minus 4. Minus 4 times x, negative 4x. And negative 4 times negative 3, plus 12. Any cleanup that can happen there? Put it in order. Which, what do you notice about the way mine worked out? It's already in order. Put together like terms if there are any. I didn't have any like terms, so I got to the end. Put it in order from highest power to lowest power. Okay? We're going to go to example 6a on the back side. Hopefully if I can get through that, we'll be good. I'm going to be pushing it, but I think I can do it. I think I can. I think I can. Power of positive thinking on this Friday, right? Okay, example 6. Finding the multiplicity of a 0. So, if a factor, and I'm going to read through this information real quick, and then more important to me is that I go through the example. because that's what really gets it for you guys. Me putting it in words, eh. So, if a factor occurs more than once, it has a, what we call multiplicity. And when you talk about the multiplicity, notice it says on your paper, multiplicity to the power of that factor. I can't do anything until it lets me put a password in. So multiplicity equal to the power of that factor. Meaning, when I ask you for a multiplicity, you're looking at an exponent. Okay. And here's the key. When we talk about the multiplicity, a multiplicity is even, means the 0 is not a crossing point, but it is a touching point. The graphs we just did on the front side, when we drew those graphs, we crossed through the 0. If there's a power of 2, it means we're just going to touch it. So you touch it and go back the other way. If the multiplicity is odd, that means that the 0 is a crossing point for the graph. Okay? So that's the key things to walk out of. Now, let me actually look at the example with you. First of all, it says, what are the zeros? What's the problem with this one? It's not factored. So if they don't give it to you in factored form, we need to factor. So, okay, let's make some quick work of this. Is there a GCF? GCF of x squared. Factor out the x squared, and I'm left with x squared minus 2x minus 8. Yes? Okay. Keep factoring. The x squared stays out front. Guess what? X squared minus 2x minus 8 does. 2 parentheses. X squared breaks into x and x. What kind of numbers you thinking? Have to multiply to be negative 8 and add to be negative 2. 4 and 2? Negative 4 or positive 2, yes? Okay, so there is our factored form. In order to find the zeros, how do I find the zeros? Set each equal to 0. So I'm going to have x squared equals 0. I'm going to have x minus 4 equals 0. And I'm going to have x plus 2 equals 0. I'm doing this in a slightly different format. Sorry. When it says x squared equals 0, you would solve that by square rooting, yes. But when you square root 0, you're going to get the answer of 0. What about when it's x minus 4? X equals 4. And when it's x plus 2? X equals negative 2. So that column are my x-intercepts, zeros. Okay. Now, multiplicities. It's equal to the power of that factor. Let me work backwards. X plus 2 has what power outside here? An invisible 1. So that means that x equals negative 2 has a multiplicity of, what number did I just say? 1. X minus 4 had an invisible power of 1. So that means x equals 4 has a multiplicity of 1. X equals 0 had a power of what? It came from x squared, and there's a power of 2. So 0 has a multiplicity of 2. Those are your multiplicities for each of them. We have one other thing. It wants to know zeros, multiplicities, and how does the graph behave? Meaning, does it cross through the x-axis or does it touch the x-axis? I mentioned up above, when does it touch versus when does it cross? When it's odd, it's going to cross the x-axis. So these bottom two are going to cross the x-axis. What about the one that has a multiplicity of 2? It's going to touch the x-axis. And that's all because even versus odd multiplicity. And that's when it asks how the graph behaves. That's what I'm looking at there. So there's a lot of answers to this problem. I mean, this whole box that I set up here is essentially your answers. Okay? The zeros, multiplicities being the powers, how the graph behaves. Is your multiplicity even or odd? And that's up in the directions, right? Okay. Your homework is in lesson 5.2, Math Excel. Let's see, was today's homework 11 questions? I think this one's only 10 maybe. Okay, so it's nothing too big. The hard part is you have to, multiply some of those out to put them in standard form on the front side. That's your hard stuff today, okay? Give it a try. Come back and we will talk about it on Monday.
Weekend.